Okay, questions? Okay, sorry about running through that, but this is where I wanted to get to, and again, keep stuff that can potentially impact IT systems. And our goal is to balance all of those threats with a usable environment, okay? So we need a secure network, but we also need a usable network. Think about the broadcast plant, how it has changed or will change. Everything, if it is transitioning to IP, it's transitioning to cloud-based services, which terms you will see refers to as service-based architecture with software as a service. Since most of us have some gray hair in this crowd, I'll use a term I ran across. Have you heard of GAAS in this context? Often referred to broadcast engineers as geezers as a service. So, but there are some young faces in this crowd, so this is unique. But anyway, that broadcast plan is changing. We've gone from what I think of as this traditional rack room to our broadcast plant, in a lot of cases, looks more and feels like more and whatever, a data center type environment. But with that comes some problems with cybersecurity. And overall, cybersecurity is concerned with protecting all of the network infrastructure, or the IT infrastructure. We really want to just focus on the IT portion. Won't read through the definitions and so forth. But there's a typical model that with cyber attacks that all begin with basically probing a network. Find something to attack. Find that target. And this is where network security comes in. We want to simply prevent someone from finding the targets, okay? Because if they don't know what target's there, there's not much it can do. Again, a lot of infrastructure threats. We want to focus in on some of on the network side of the house, not overall on IT security. So again, some terminology that when, for instance, when someone says, well, I have a secure network, what does that really mean? Well, there are some attributes that are associated with defining a secure network. This is one that is often overlooked, is the accountability side, or the monitoring and logging of activity side. In other words, being able, when there is some incident, being able to reconstruct it to understand what happened, so then you can take some protection against that. Just some terminology that you'll find. This CIA triangle is often used to kind of describe the three sides or the goals of security: confidentiality, integrity, and availability. And by the way, the CIA has the term CIA in this definition has nothing to do with a certain government agency. There's attributes of policies is usually a starting place within organizations. A large company is going to have probably a very involved security policies that are general in nature at the top, but translate down to very specific procedures at the lower levels of the organization. Again, some terminology that you might run across or will run across. Asset is simply anything that has value within the network infrastructure. And of course, that threat is when there is a possible danger to that system or that information. And of course, there's always risk. There might be a threat that's out there, but the risk might be real low. Thus, it might be overlooked. And as a result, an exploit can happen. And of course, a countermeasure is the action or how you mitigate that. The most important thing, though, to remember or keep in mind about security, it is a continuous process. It's not something you do and say, okay, I've done security, I'll move on to the next project. It is a continuous process, often described as the cat and mouse game of monitoring and assessment and, again, creation of policies and stuff. The best way to look at one is to create what is referred to as use the castle approach, also described as the defense in depth approach, where you use the principle of a design of a castle. What you always think of castles, always think about the moat around the castle, and there's usually different levels of walls that exist. So if you happen to breach one area, that doesn't mean you've gotten access to the core. The same principle in network design. And this is where our network segmentation or separation comes into play. And you create different security zones with different control aspects, with the core being at the center. So again, a lot of, what I'll call textbook knowledge or textbook terminology about security, but how do I take all of that and do something from my practical station at my radio station or my TV station? Well, one way I'd like to suggest to do it is follow the OSI model. In particular, follow the data flow layers. Use that as a guidebook. So with that, if I can convince you of that approach, how do we do that? Well, let's start what? At the physical layer first, because that's where we started building our network. And we implement physical controls, which simply is controlling access to stuff. In other words, restrict physical access to that network infrastructure. That's often done through cages and locked rooms and security cameras, once again, to be able to monitor things, have an audit type trail. We can use then at layer 2, we want to use Ethernet switch port security features that we can restrict what can be connected to a switch port. Ideally, we said we want one host device per switch port, but there could be some situation where we need more than one. We could limit the number of addresses that could be attached to this switch port. We could limit the hosts that be connected to specific MAC addresses, okay? And if a violation occurs, there's several things that can be done, but generally you're going to shut down the port so that, yes, I plugged in, but I'm not going anywhere because the port has been basically shut down. The other practice is to simply disable unused ports. By default, most switches are going to have all the ports enabled. Going to be member of VLAN 1. Okay, so you want to go disable any of those access ports. And certainly you don't want to leave trunk ports open. You only want to use those, and you only want to put the VLANs you need on a given trunk link, rather than, for simplicity, let's put all the VLANs so I'll have them everywhere if I should need them. Well, don't really do that. Put them really where you need them. And again, we're going to segment this traffic in these different zones. We talked about doing it for performance, but now we want to do it for security purposes. Again, some of the violations and the actions that can take. Most switches will have a feature referred to as sticky MAC learning. I have a 48 port switch, and I'm going to have 48 hosts plugged into this switch. Do I want to type in 48 MAC addresses? Probably not. So they have a sticky mode where you can connect your host devices in a controlled environment. You can like take a snapshot of all those MAC addresses and capture them, okay, and build the table. So it's sometimes the configuration is not quite as bad as it sounds.
Let me ask you a question. If you have a MAC address, is it possible for somebody to actually sniff the transmit direction only from a host? And like every packet has a MAC address in it, I guess?
Every frame has
Every
a MAC.
frame, okay. So every frame, so you could sniff it, pull the MAC address out, and can you, what do you call it, spiff the MAC address? So will I guess then the question is, if somebody disconnects a port, like you're gonna disconnect it and plug your new device in there, can just disconnecting the port and plugging it back in make it shut down? In other words, how
Not aware of that being an option in any way, but you can spoof. You know, we talked about MAC addresses as a unique address to a host, but MAC addresses can be spoofed. It's real easy to spoof one in a Windows host. There's tons of utilities out on the internet to do that, because what happens in the Windows operating system, yes, there's a MAC address and that hardware-based address and that network interface. During the boot up process, that operating system reads that address. Now it resides in memory. So these utilities, all they do is go change it in memory, and it's good until at least you reboot the host device.
That defense then on that port thing is not necessarily that good then.
Not that good. So,
Okay.
you know. Okay, after layer 2, we're of course at layer 3. This is where we want to implement layer 3 security, which is generally going to fall in two categories of encryption or implementing firewalls. Okay, and firewalls can be implemented in several different areas. Similar to firewalls or access control list, and they are several application security features that can be implemented. An access control list is really kind of a very basic network access security buffer. It does packet filtering. We can implement that on basically or block forwarded packets on an egress interface. In other words, we can block certain packets going outbound, or we can block them coming in. This would be an example that I used where we want to block someone from pinging our internal network from the public internet. We would simply, the simple way would be to implement an access control list on my border router on the ingress interface. In that case, if I want to block ping, what is it based on? What protocol? ICMP. I just simply block ICMP on that ingress interface. ACL, there's some rules associated with them. The basic or the standard simply only lets you permit or deny the source IP address, okay? However, an extended access list pretty much lets you block anything that is in the header or most of the important stuff, and this would be one where I would basically, if I wanted to block pinging, I would basically block the ICMP protocol. Or particular applications that use certain port numbers, I could block those as well. So to implement, again, there can only be one access control list per interface direction. Of course, an interface is bidirectional, so it has an ingress and an egress side to it, but I can only have one access control list. However, an access control list can have multiple statements in there. And again, assuming I'm using, I can again permit or deny different factors. So basically, you create the list, then you apply the list to a interface. And this is a simple example of I want to block basically someone to be able from the public internet to ping my internal host devices, I just create an access list and I apply it, in this case, to this ingress interface. And in a Cisco environment, this would be the actual commands that would be used to do that. Again, firewalls are really our tool to use. They are two types of firewalls: a packet filtering firewall, which is effectively what an access control list does. In other words, it's a fixed configuration, whereas a stateful packet filtering firewall is conversation or flow based. In other words, it's aware of the traffic. There are also tools, generally under the category of intrusion detection, that can look for threats and attacks and so forth, either based on a signature referring to a pattern of activity on the network. So in other words, if someone is port scanning all my IP addresses and ports, that's a signature to that. That's easy to detect, okay? And if I have that intrusion detection system tied with in the context of an intrusion prevention system, which integrates with a firewall, I just simply block that source IP, all of it, dynamically block it if this signature occurs. And there, of course, also is a novelty-based one as well. So again, the firewall types, we talked about the stateless being basically just like a access control list, whereas the stateful was conversation-based. Firewalls can be software. pfSense is a pretty popular open source program that is often used, and firewalls can be hardware boxes that often have graphical user interfaces that can make them easier to maybe configure and so forth. So implementation, a typical scenario is what is referred to as the three-legged firewall, or the three-handed sometimes, where again, because we want to establish security zones, we're going to establish one that is referred to as a DMZ, or demilitarized zone, that has security provisions or capability, but it is not as tied as my internal network. And here's where you might put devices that need public access, such as a web server or an email server. However, the type of packets to those devices is limited to certain protocols associated with web servers and email servers. The stateless or a stateful firewall simply blocks everything, whereas in the stateful, again, it's conversation aware. And if someone on the inside originates a conversation to the outside, the firewall is aware of that, and it permits that return conversation. Think back to that three-way TCP handshake that occurs between devices. At the same time, there's some caution that comes into firewall use. Simply because I have a firewall doesn't mean I'm done. There often can be a false sense of security with a firewall because, one, the firewall is not doing what I think it's doing or should be doing. I haven't updated it in a long time. So you have to be careful with that. It's also a good practice to minimize how much or how many hosts that I am actually trying to protect. In other words, in my segmentation, I might want to also minimize the zone that I'm protecting. There can be or will be a performance impact that may or may not be a problem for you. That performance impact generally is in the throughput and the latency. And finally, don't overlook egress. In other words, protection for what goes out of my network somewhere else. In other words, be a good network citizen there. Some of the common ways to do security, IPSec is the most common. It is an optional implementation in IPv4. It was added to IPv6 and recommended to be a mandatory. Actually, in the original IPv6 specification, it was mandatory and was later changed to a recommended implementation of that. A couple of ways to do IPSec through either a tunnel or the transport mode. And once again, we're taking what normally fits in the payload and we're adding additional information and encapsulate it. In this case, we have some payload. Again, we're at level 3, so we have some, within the packet, there's some payload data. There's what? A layer 3 header associated with that. Now we're going to add this ESP header to that. That is basically, or this ESP information in a header, it's basically the encryption part of that. So I can encrypt now that whole packet. So let's talk now about hacking. There's really two terms. Hacking used to be kind of a something you were proud of back in the early days of IT. Today, hacking generally is associated with not so good things, and there's been some terms associated with hacking referring to a white hat hacker or a black hat, and even the gray hat has emerged. Well, the white hat, we're going to be white hat hackers today. Our intent is to protect our IT system. But to do that, we're going to use hacker tools to be sure our IT system is really doing what we think it should be doing. The intent in the black hat is to do some type of harm. That may be to get your credit card information or your bank account information. It may be to take your radio station, TV station off the air. It may be to, let's see, what has happened? Replace your programming with something totally different than it should be. Okay, there's an intent. It's there to steal information. Okay, like the big Sony breach, that what was some movie that, yeah. So anyway, the intent is to do some type of harm. There's also the gray hat hacker, which really is, this is probably the one, if you're going to get hacked, you hope it's a gray hat hacker, because really their goal is to just the challenge of doing it. They're not out to harm anything. They just want, because you just told me you have a secure network, right? And I'm going to show you it's not so secure, and I'm going to show you how I got into it. It's that challenge of doing that. Okay, but this is the ones we have to worry about. All of the different threats that are out there in the network side can really put into 3 generic categories, that they will have different names. The details will be different, but kind of the fundamental what do they do are all will fall really under one of these 3 categories. The denial of service attacks is probably the most popular or most frequent network attack. Spoofing is used again to basically make you think a host is somebody it's not. And particularly the DNS is one to basically redirect traffic to somewhere else. You think you're talking to your region's bank server credit account. It looks just like that, but what you're really talking to is a spoofed site, okay? And they're out to, again, get the credit card. Does anybody know what a valid credit card number information record is worth on the black market? You may have an idea what those are worth. They're worth about $5 a record, is what. And they are hackers. Their sole goal is just to get information. And what are they going to do with it? They're not going to hack, or they're not going to do it. They're going to sell it to somebody else. Okay. And by complete information, that's enough to use it, which we know now we have PIN numbers in addition to the credit card, all of that information that is needed. That's about what the value of it. It used to be a lot more, but the hacking is a competitive business now in the black side of the internet.
Shut down real quick because you get a text that says somebody just charged $100 on your account, and then you immediately say, no, I didn't do that, and you shut it down, but yet they've done $100 right there.
That's right. That's right. So that's where you hope your bank that you're doing business or your credit card company has really, really good, not intrusion protection, but again, there's similar fraud pattern detection. They see Wiley has charged something that does not fit Wiley's pattern of maybe where you're at or what you're buying or whatever, and their fraud protection block it. It could be a very legitimate purchase.
You just don't act normal, they're going to shut down your credit card.
That's right. You're not doing normal. I was at the Huntsville Hamfest last year, and I bought a gadget from Gigaparts. Handed them my, a Bank of America card, and they denied it. I said, oh. So I pull out another credit card, and I get my gadget, and I go on. And I got 2 steps out of the booth, and my phone text beep. It says, Bank of America card fraud. We have detected unusual activity. Please call us, So they're pretty anal about that. I've had that problem several times. Yep. This Apple Watch I bought at the Apple store in Las Vegas when I was out at NAB, tried to use that Bank of America card, and they flagged it. They called while I was standing there in the store, and I told them, no, I'm trying to buy this Apple Watch, and they said, then they said rerun it again, and it'll go through. Anyway, getting sidetracked here. Again, some really quick examples how spoofing works, particularly with the denial of service. You just flood, basically, a host device with what are often referred to as their one-way handshakes. In other words, I issue that synchronized command to initiate that three-way handshake, but I don't do the rest of it. I just flood that host with traffic. And I do that maybe for multiple locations in a distributed denial of service attack. And in fact, some of the large denial of service attacks has involved thousands of locations that basically flood a host device with traffic. Spoofing, again, is where this is often referred to as the man in the middle, where you make a host think it's something else. I use a feature of the protocol called gratuitous ARP. We did not talk about ARP really a lot, but ARP is the address resolution protocol. And remember, a host device has to have 2 addresses to initiate across the network. It needs a MAC address and it needs an IP address. Okay. Well, I have a MAC. I know what the MAC address is. How do I know what the IP address is? Okay, I know what the IP address is I want to reach, but how would I know what the MAC address is? Well, that's what the ARP command does. It gets an address. A gratuitous, instead of the host having to get that address, it basically advertises. It's a feature that allows a host to advertise. It's like this host comes onto the network and says, hey, here I am. Here's my MAC address. Okay? But that can be used to exploit things as well. So again, I can issue these gratuitous ARPs that now point to this device as being where I may think. Then there's also where in DNS, of course, DNS is where we do not know an IP address, but we know a name of a server like www.sbe.org. And DNS gives us basically that IP address. But I can also then basically, again, direct legitimate DNSs to a malicious server that's going to return really a false IP address that's now going to take me to, this is typically where the companies that are doing credit fraud, you think you're talking to your bank with your whatever bank account, but you're really not. Okay. Again, some stuff to mitigate some of this, and this is where I want to get to. Let's be, for the next about 30 minutes, let's be a hacker. There are tools out there that hackers use, but we want to use those tools to verify what our network is doing. Is it doing what we think it's doing? One of the most popular is Nmap. It is an open source tool, and you'll see a URL to download that. There's also a companion program called ZenMap, and ZenMap is a graphical interface for Nmap. And we're going to actually use ZenMap for my examples here. There are a lot of similar tools that are out there today, but they all share a common foundation characteristics of Nmap in terms of doing network scanning, which you've probably heard of that term. You should be aware that there can be specific legalities associated with network scanning. There is no current law in the United States against scanning networks. There are in Europe, but not in the U.S. So there's no criminal law against scanning networks. Okay? However, most, if not all, ISPs will have appropriate use policies and stuff where you'll just get, service will be denied if that kind of activity is going on. So in our context, we want to use this, though we're going to scan our own network. So I'm assuming it's my network, I can scan it. If I'm going to scan Bob's network, I need to go ask Bob, is it okay if I scan your network? Bob may even pay me to scan my network because I'm a security consultant. And there are companies that this is how they make really, really big bucks, is scanning networks, looking for penetration attempts. So again, be aware that there are at least some ethics involved. And the biggie, particularly in a broadcast network, be careful with doing aggressive scanning because you can crash the host. The host device could be a codec that my program stream. That could be maybe a content server. Because think about a lot of devices in our broadcast plant that are really host devices, and I see a couple of EAS boxes over here. Yes, there is a IP host. There's a computer in there, okay? But maybe those, a lot of times in devices like that, that host is not that robust in terms of processing power. Okay, its job is to do whatever it is supposed to be doing. Doing some of this IP stuff is not, there's not been a lot of resources put in it, particularly in an embedded system, because often the IP stacks are pretty fragile, and aggressive scanning can crash one of them. So be careful in a production environment doing aggressive scanning. Again, scanning is not a crime in the U.S. There's a really good link in the Nmap website about some of those issues, particularly worldwide. And the concept is kind of like, is it against the law to open an unlocked door? Well, yeah, but think about it. Just because I didn't lock my door, does that give you the right to enter my residence, for instance? Well, now that's the practical side. But again, does that... Yeah, so this kind of the same thing. There's kind of this accepted boundary that exists. So again, that sort of applies to network scanning. So what can you do with Nmap? Well, you can determine active network host. You can obtain information about that host by determining its operating system. That lets me know something about it. Possible some, vulnerable points of attack. I can find open ports. If I find open ports, that says, there's could be a service attached to that port. Okay. And also, though, handy things, I can diagram a network, which can be very handy too, particularly if that's an unknown network environment. And some of the network diagrams can actually be useful, if nothing else, to capture all the IP addresses.
Okay, like on a computer, if I go on a computer and I access Google or so, and Google says, comes back and does a thing and says somebody through Google Chrome on a certain operating system enter this thing. By me not saying I want to, because I try to always not identify that I want the computer to know me as a regular person, because if Larry decided to get on my computer and start pulling up my data, then because sometimes you let somebody use your computer, and you don't want to have somebody going in and hacking on the thing. Mm-hmm. Now, if he went in there and says, yeah, you know who I am, you know what I'm saying? It asks the thing. Is that going to does that defeat that purpose or not?
No, not really, because this is kind of separate from that interaction, that what I'll call a client-server interaction that's going on. Google is doing their own little thing in there. They're logging. They have obviously a login ID associated with you.
I like to have them asking questions, because I feel like they're asking questions.
And they know where you're typically accessing from. You're accessing from, a IP address, a certain host MAC address. They know they can capture that, let's say, from your cell phone when you're accessing them. So they know your patterns, and now all of a sudden, here's this new device comes along. Well, that new device could be the new computer you just bought, but it also could be somebody else trying to be you as well. Access your account.
Sometimes I go to the library and I'll access I got Gmail, and I'll access it. And when I access it, I'll get back at home at night and look at my other computer.
They'll say
they'll send me a message saying that somebody.
And if you've implemented the two-factor authentication that most services have now, you try to access something from there.
Also another thing it does, when it sends that prompt, it knows enough not to send the prompt when you're using that away computer. So in other words, if I'm logging in using that library computer, and I go to my email, put Gmail in there, you won't see that question asked.
Right.
But if it's your normal computer, a question, I noticed that it's other questions will come up, and
you could get a text within security alert and said, like your thing, but he says somebody's logged in on your computer, and you say, well, there's nobody at my computer. It's at home turned off. But, that's part of that alerting service that they're doing. So let's do some basic network scans. This is what Nmap looks like. Again, Nmap is a command line, so it's pretty boring, actually. I've scanned a particular server or an IP address. I really don't know what it is. But I found, it's got some ports open or available, HTTP and Telnet and SSH. So I found a host there. It's got the MAC address. It's decoded the OUI and say, that's a Cisco is who it's registered to. That's a basic one. Okay, but it's also kind of boring. So we're not going to use, we're going to use ZenMap. We'll do that same scan and we'll get something that maybe is a little bit nicer. And I like ZenMap, particularly for demonstration purposes, because you can simply enter a target IP and you can use their dialog boxes and actually configure it. Whereas in Nmap, really you command it back in the command line mode. You enter all these switch characters to implement the different options. The neat thing about ZenMap, I can use these checkboxes and stuff or different menus, but it will actually show me the command switch characters that build that command, and I'll show you some examples of those real quick.
Any of those dangerous right there?
Well, it depends. Should I have Telnet open on this device? Probably not, because Telnet is not considered to be secure because it does not encrypt passwords. All right, this device happens to be in my internal network, and there's a firewall external to this protecting it. So in this particular, it's probably not good, but it's okay. And if someone gets into it, they're not going to really, I guess they could take my home network off the air, but okay, I can put it back real quick. Otherwise, SSH, that's how I get into it externally if I need to change something, and certainly HTTP as well. So in general, that's probably okay. You can create all, yeah, I don't know. Anyway, there's a lot of things. We don't have time to run through all of these examples. This is some of the popular things you might do, but I do want to show you a few of them. This is a sample. There's approximately 100, actually there's over 125 individual commands that Nmap can do. So I want to show you a few more. Again, we've really kind of seen the same thing here. This is one I can scan a range of IP addresses and build a sequential list. Of course, I create a lot of information. And again, this is just a screenshot of kind of what is readable. But I found a particular host at this address. It's got a whole bunch of stuff that at least the ports are open, which says those ports are in use. Again, I can scan a whole subnet. I'm going to use the CIDR notation to indicate the size of that subnet. Okay. I can do this aggressive scan. This is now where I can get more information, and that's determined, this aggressive scan is determined what this device even is. It is a Cisco AeroNet access point, actually. Actually, it's a Ethernet radio. It's found, to return the version of the operating system. And for a hacker, what good is that? Well, there's known vulnerabilities with certain versions and certain types of operating systems and so forth. Again, default passwords, and I have a really good example to show you at the end here. Again, it is also can be useful to you to build a little map of particularly IP addresses. This is a fairly simple one with just a few host devices. Again, you can determine operating systems, although there are times when it cannot figure out what it is. This is an example where it's determined, okay, it's a Netgear device based on the OUI of the MAC address, but it can't figure out what the operating system is for whatever reason. And it just so happens that's a Netgear access point. That particular device happened to be. I can do a fast port scan, which is simply, by default, Nmap scans the top 1,000 ports. Remember, there's 65,000 of them UDP and 65,000. I could scan by using the command or the configuration. I could scan all of those if I felt I needed to. By default, Nmap scans the top 100. A fast scan simply scans the top 100. So we can move along a little quicker. The real key is the scripting. This is what typically is used by the hacker community to do these scans. There's not someone sitting in a dark room in front of a computer. There's a computer somewhere that is executing scripts. And depending on the results, there could be even further actions that are scripted. So this is one of the really, really powerful tools of Nmap. And particularly some of the other tools that are sort of derivative, that are built on the basics, what they're doing is doing specific types of scripting to do specific types of things. It's going to rain at 4 o'clock. Okay. Let's look though at some scans of some common devices. I am not picking on any individual manufacturer. This happens to be equipment that I had access to. What can we learn from scanning a EAS receiver, decoder, encoder? Well, we learn all that stuff. Of course, you can't read any of that, right? And that's only a portion of what's returned. So let's kind of blow up some areas particularly of interest. We found several ports that are open, okay? Port 80, 443, 22, 631. If you do a lot of this, you sort the common stuff you remember, okay? But it's also, and we can also find out more. We see what version of SSH is being utilized, okay? Do I know of any vulnerabilities with version 6.9 of SSH? I don't know if there are, but if I did and I was really good, I would have a script that says, got here's SSH 6.9, here's known vulnerabilities. I have a script that tries those out, okay? Again, what are these devices open? Well, I can certainly go look up the port numbers and say, well, okay, those all look legit, but what is this 631 IPP thing, okay? Maybe that's okay, maybe it's not, but that's what's there. Those are actually all legitimate for that particular equipment. Again, a URL that's real easy to look up the port numbers and the services. If you're in the public radio environment, you're probably familiar with these receivers. I call them the Content Depot receivers. Again, a scan, we find a whole bunch of stuff open there in terms of ports. And again, we can extract some information. Happens to be a older version of SSH that's being executed there. They're using a fairly old version of the Apache web server. We know that's full of all kinds of interesting holes and so forth. We go look up those port numbers, and what in the world? Why is the Amiga file system on a Content Depot receiver? Well, those port numbers, this is a registered port number. It's not a restricted one like 21. It's a registered. So way back when, Amiga, which made what? Computers in the early days, they registered port 21 to be used for their file system. Okay? What is Content Depot doing with that? I don't know, because there's nothing to keep you from using that port number. It just so happens it was registered back in the day to Amiga. So again, you have to sort of have a little bit of understanding to some of the meetings. In 679, what in the world is that? Well, look at that. It says it's a threat of the W32 Netski. Well, does that mean this is infected? Not really. It just that port number has commonly been used with that particular threat. And thus it shows up of there's 4 things that have been identified in the past associated with that port number. Another device, again, nothing particular. Obviously, there are open ports and so forth. We can find out a little bit more information about it in terms of the operating system. Again, notice it says, we couldn't figure out what what the operating system was. So it gives you a suggestion of a different command to try to maybe be able to figure out more about this particular box. And what about the famous barracks boxes that we have all heard about, the barracks box problems in the news? What is so insecure about them? Well, let's scan one. We come up with something, and gosh, there's not just a whole lot here to worry about. Gosh, there's only one port open. And it's port 80. That's pretty common. Yes, we found out about the operating system and some of the internals. With a barracks box, there's really nothing inherently insecure about in terms of the operating system. The problem with a barracks box, they don't have any default login information. They're open. Now you can put login information in them, but you have to go do that. There's no default login information. Is anybody familiar with the website Shodan? If you're not, I suggest you spend some of your leisure internet time exploring Shodan.io. I don't know where the domain .io is registered to, but it's not the U.S. Shodan originally was associated with the consumer Internet of Things. Internet of Things is all of these internet-enabled devices typically found or originally found in the consumer market. How many of, we all have IP security cameras. You may have one of the, the Nest thermostats that you can set on your iPhone. Anybody have one of the Philips IP addressable light bulbs? Okay, there's all kinds of stuff out there. Yes, you can, your car emails you or texts you and stuff. Yep. Anyway, that's kind of where Shodan was out. Shodan is, again, another version. Again, its foundation is like Nmap, but it's got a different interface. It's got a web interface to it. You've probably read some of the stuff about people snooping people's security cameras and stuff. I don't know what I'm going to see if I get into your security camera. Maybe I'll see something interesting. Maybe I won't. It's some of this, again, that if I have my gray hat on, it's the challenge of doing it. Other people are looking for, something that maybe could be gained from that. But anyway, that's where Shodan came from. So let's take Shodan, and let's use the search term Nautel. Okay? And look at that. It came back with several IP addresses. Look at that on the open internet of Nautel, basically transmitters. This particular scan was done. When was this done? This was done back in, Bob, tell me when this was done. When was the Albuquerque convention? Okay, this was done a few days before that. I was at Albuquerque. I did this scan, and there's 6 devices. This morning at breakfast, I did this again, thinking, those things won't be there now. There's more there, or at least was. In fact, I can show you on my iPad. There's more of them now.
If you did a scan like this, that's going straight to that IP address. If that IP address, let's say that went to a a router that was port forwarded or whatever. Does it go on through the port forwarding to find it?
Maybe, maybe not. We are going to assume there should be a firewall to prevent that kind of stuff from doing. You should not have, in my opinion, a transmitter control system on the open internet. Okay? Well, you do want to be able to control that transmitter, but you don't do it on the open internet. You do it through a secure mechanism like a VPN or something to get to it. But anyway, there they are. Now, the interesting thing, there is one of these IP addresses that has the default login information to it. I'm not going to tell you which one, but there's one of them that has the default login information. Well, what could you do with that? Well, if you're familiar with the Nautel GUI, you can bring that up. What can you do with that? Well, real quickly, I could click this box right here that says RF off. This is real. This is not dummied up, made up. This is real. In fact, I hope by now this is gone because Jeff Welton from Nautel took the serial number that you can also get from the GUI and went back to their records and see whose transmitter this thing really is. So first of all, you shouldn't be able to, even be seen, because remember, the first step to do is to not let somebody be able to probe your network. So there's the first violation. And for sure, you want to change default login information, because you could. Yeah. Well, Jeff knows it because Jeff is the one who originally told me about some of that. And but just think what could you do? All right, I'm going to turn the transmitter off. I'm going to go over here to the menu and I'm going to now put some unique login information into this transmitter. Okay? The legit person now tries to dial in. They can't log into their own transmitter. Okay? Well, they possibly could. Certainly, if they got into the barracks box that might be associated with it, they could do so. There's a lot of, again, a lot of times common sense will stop some of this. This particular. Well, that's right. I didn't think about that one. That's how, you could.
Change the power level,
Yeah.
change the modulation.
Let's hope Nautel's GUI won't let you take an FM transmitter and put it over on an FAA. Let's hope their GUI has some error checking, that keeps it at least on a broadcast allocation. But you could real quickly cause a lot of grief. So anyway, again, just some other stuff about risk to particular broadcast stations. Some best practices to do. Again, I cannot overemphasize change default login information. There's actually a pretty decent document that exists from the FCC called the FCC Working Group 4 document, and that's something worthwhile to go reference. However, when you go to this URL, which I admit is really a convoluted one, but if you do a Google on FCC Working Group 4, it will take you to this convoluted URL. Don't panic, because you will find this 400-page document. You're really only interested in section 9.1 that focus on the broadcast segment. It actually is a pretty good primer on security in the broadcast environment. It's got some checklists and stuff in it. It's got some reference diagrams for both radio and TV stations in terms of security architecture, but the true value probably is about 10 or 12 pages of these systematic checklists of things to consider in developing a security plan. Also, I'll call your attention to this particular document. The author of that, or the lead author of this document, is sitting with us with the headphones here. The SBE has a group called the ES Advisory Group, which Larry chairs that group. And they've produced this document that it's just some recommendations of things to be done, particularly this was in the context of some of the EAS type hacks that has occurred. So again, some reference information. So our challenge, again, balance security and usability. And let's time for some questions. Before I do questions, though, there's some takeaway points from each of the sections. We won't read through all of that. Those will be in your handout packages. Kind of a big question that always arises at times is, when do you route and when do you switch? Well, we want to route to limit a broadcast domain and provide interoperability between networks. We want to minimize a security or a collision zone, so we have 0 collisions, and we do that with one host per switch port, and absolutely we want to get hubs out of our network design. Just a couple of other references. We follow a frame through a network, and remember, a frame also has an embedded packet in there. So simplified versions, as this frame moves through the network, the MAC address is only valid on a given segment, and it's going to change as that frame moves through the network. The IP address is going to stay the same, except if there's NAT involved somewhere along the process. Some security points, we've covered those, and then there's a whole bunch of reference charts. I have some handouts that I brought with the idea, particularly the subnetting chart, in case we had some time to do some subnetting exercises. And if you're interested in those, grab one of those on your way out the door today. Another handy reference, if you find yourself working in an environment that has Cisco and HP equipment, okay, to be able to translate the different commands between the two. That's the most worst environment, where you have mixed equipment and you're typing HP commands into a Cisco box or vice versa. Kind of a handy document. And again, it's a fairly lengthy document, so this is just a kind of a screenshot or part of it. We talked about subnet calculators. This is one particular one that I like. That's an iOS-based subnet calculator. It's always good to have one of those. Another, we won't spend time working through reverse engineering, but remember, every IP address, what? It must have a subnet mask, okay? With that information, I can kind of reverse engineer a network to do that. That's real easy to do with a subnet calculator. It's really not that bad to do manually. I just have to do a little bit of binary manipulation. And again, I won't walk through that, but I think the handout will pretty well explain how to do that. That can be, though, really handy to do, particularly if you're in a facility and there's no documentation and nobody knows anything about the network. Particularly from troubleshooting. Some reference texts that, or at least my favorite ones, regarding networking. And also, of course, in the SBE Engineering Handbook is a section on information technology in the broadcast plant. And always remember, there is more to networking than just hooking things up. So with that, thank you for your time today, and I will welcome any questions.